Welcome to a new class. Today we are going to discuss acids, bases and salt. And first class we have discussed natural indicators, China rose indicators, turmeric indicator and litmus indicator. And you have seen the color change when we apply acids and bases on these natural indicators, isn't it? You may be wondering what happened when we acid react with a base. We are going to discuss the reaction between acid and base today. We have taken this dilute hydrochloric acid and dilute NaOH, that is sodium hydroxide, dilute HCl hydrochloric acid, dilute hydrochloric acid and dilute sodium hydroxide. What happened when these two mixes together? See, when we mix a suitable amount of acids and bases, the resulting solution will be neutral solution. The acidic nature of the acid get lost and the basic nature of base also get lost. The resulting solution will be neither acidic nor basic. During this chemical reaction, heat energy is evolved or it is released. And if we touch the test tube soon after neutralization reaction, you can feel the test tube hot. Why? During this chemical reaction, heat energy is produced or evolved. So that heat energy produced heats up the reaction mixture. That is why we feel hot when we touch the test tube soon after neutralization. So let us perform an activity to understand the process of neutralization. Last class we have seen natural indicators. Today we are taking another indicator called phenolphthalein. This indicator is called phenolphthalein. So, phenolphthalein indicator. By using this phenolphthalein indicator, we are going to demonstrate one neutralization reaction. See, I am taking some amount of dilute HCl, that is hydrochloric acid, in a test tube. Okay, I am adding a drop of phenolphthalein indicator. Okay. You can see no color change happened. So, phenolphthalein indicator do not give any coloration with acid. That is the nature of phenolphthalein. The second test tube, let us take some amount of sodium hydroxide. So, into this sodium hydroxide, into that also I am going to drop a drop of phenolphthalein indicator. Yes, you can see the difference here. Now, the color turned to pink color. So, phenolphthalein indicator give pink coloration with base and no color change with acids. With acids, no color change. But with base in pink color. Okay, let us take small amount of dilute hydrochloric acid in a beaker, and I am adding 1 or 2 drop of phenolphthalein indicator into it. See, the solution is colorless. Okay, the phenolphthalein is not making any color change in the acid. Now, let us add sodium hydroxide, dilute sodium hydroxide we can add into this acid drop by drop. By using a dropper, I am going to add this dilute sodium hydroxide into this mixture. So, continue adding that, and after adding you have to shake the mixture well. Continue adding this sodium hydroxide into this mixture. You know, now the neutralization reaction has started. This acid molecule present in this acid is getting reacted with sodium hydroxide. So still this solution is colorless. What is the meaning of that? Here there is acid. The content of acid is more in this beaker. That is why it is reacting like this. See, continue adding this sodium hydroxide into it. If you go on adding this sodium hydroxide, when we add suitable amount of sodium hydroxide into this hydrochloric acid, what happened? All the hydrochloric acid molecule present in this mixture get reacted with the sodium hydroxide and get neutralized. So we have to go on adding sodium hydroxide into this hydrochloric acid. So each add one more drop of sodium hydroxide into this acid. See, now solution become pale color. Add a drop of, when I added one more drop of sodium hydroxide into this acid, you can see this a slight pink coloration now. So at this moment, so we can say that at this moment all the hydrochloric acid molecule present here get reacted with sodium hydroxide and this beaker gets slightly heated up. During this chemical reaction, heat energy also get produced. That heat energy heats the reaction mixture and we can feel that heat in the sides of the beaker. At this point, all the hydrochloric acid molecules reacted with sodium hydroxide. So we can say that this solution is neither acidic nor basic. The effect of hydrochloric acid is neutralized by sodium hydroxide. Let us test this solution with red and blue litmus paper. So first I am testing this solution with red litmus paper. So red litmus paper I am dipping into it. See, red litmus paper remain red. What is the meaning of that? This solution is not basic. Now I am testing this solution with the blue litmus paper. So let us take a blue litmus paper and test the solution. See, blue litmus paper remain blue. It means that this solution is neither acidic nor basic. Why? The effect of hydrochloric acid is neutralized by sodium hydroxide. Now let us see what happens if we add one more drop of sodium hydroxide solution into it. And into this neutral solution I am adding one more drop of sodium hydroxide. See, solution again become pink color. What is the meaning of that? This solution is basic in nature. Now the amount of base is more. That is why this phenolphthalein, phenolphthalein give pink coloration with the base. So now the solution is slightly basic. So let us add one more drop of hydrochloric acid into it. Let us add hydrochloric acid. See, solution again become colorless. Why? Again, this effect of sodium hydroxide is neutralized by hydrochloric acid. This reaction is known as neutralization reaction. So what is neutralization reaction? The reaction between an acid and a base is known as neutralization reaction. So acid plus base gives salt plus water plus heat. Heat energy is also liberated or evolved during this chemical reaction. One example is the sodium hydroxide plus hydrochloric acid gives sodium chloride plus water plus heat. Heat energy is evolved. And see, let us see the chemical equation for this reaction. NaOH, that is sodium hydroxide, plus hydrogen chloride or hydrochloric acid HCl. So NaOH plus HCl gives sodium chloride, or it is the common salt that we use in our cooking. We use the table salt. Sodium chloride is the salt that we use in our kitchen as table salt. So the products are sodium chloride, water and heat. How this reaction is taking place? You can see sodium hydroxide contain this OH, and this OH react with this H, and this combine to form H2O. That is how H2O is formed. OH plus H. So H2O is formed. And NaCl, how it is formed? This sodium react with is combined with this sodium combined with chlorine and form sodium chloride. So this is an example for neutralization reaction. Neutralization reaction has many importance in our daily life that we will study in the next class. See you.